Hello everyone, welcome to class. In today's class, we'll talk about cognitive computing. This is also a series in our AI course, and we're looking at cognitive computing, which is more of mimicking human thought. So basically, when we talk about AI, I've always said that AI is building machines to the level of intelligence of human or even surpassing intelligence of human. And we've looked at augmented intelligence, can get back to that video, and artificial intelligence. And what we are really seeing now advancing is augmented intelligence, at least for everyone to see. So when we talk about cognitive computing, this is a very specialized area in artificial intelligence, and we are looking at simulating and augmenting human thought process in decision making. So the question is, what do we describe intelligence as? So is intelligence ability to remember things easily, like memorization? Is intelligence ability to be excellent at games of chess? Is intelligence ability to be emotionally intelligent? Is intelligence ability to solve problems easily? Is whatever we think intelligence is, AI is encompassing all of these. And it has been trained with cognitive ability, which is the residence of humans. Humans are the ones that has cognitive abilities. So when we talk about cognitive abilities, we're talking about our human thought process. When we think, our thinking goes through a thought process, and when we want to make decisions in complex, uncertain situations, we actually run through a thought process. So if machines can be able to run through that, they'll be able to give information that is well thought of, reasoned out, and we at most be able to mimic humans in the closest way it can. So generally, when we talk about making machines intelligent in various ways, cognitive computing especially focuses on building systems that can reason, learn, understand, and interact in a manner that mirrors human cognition. Okay, that's great. So now let's look at key characteristics of human cognitive computing. Okay, that's great. The first is mimicking human cognition. All right, so when we look at that, we look at humans think in very funny ways. All right, good. So we want to simulate how humans reason, because we reason in the form of tree through neural networks, and then our decisions actually go through different points. So we are simulating that with machines, where machines can be able to process information, learn from experience in making decisions. So like we gave an example of a child. When you are growing up, you learn language from your environment. Most of it, you hear what people are saying, and even when you say the wrong thing, you are corrected. You learn from that experience. So generally, we learn from experience over time to better and build ourselves. And that's what machines are built to do now, with the advent of machine learning. So machines can be able to make decisions based on learning from experience, interacting with the world, and so now it includes things like perception, attention, memory, reasoning. So a perception is the ability to see, interpret images, videos, speech recognition. Attention is the focus on relevant information amidst large amount of data. So that means, the machine is able to spot patterns. Like if you train on it, you can train the machine on the difference between cats and dogs, right? So you put cats in one place, you put dogs in one place. So it's able to spot the patterns to be able to recognize the difference between a cat and a dog and a ball, whatever it is. Then memory is ability to store and recall information, including contextual details from past interactions. Reasoning is where you draw conclusion from hypotheses, evaluating options, look option A, option B, option C, then trying to look at which one is the best for this situation, and looking at contradicting information also. The learning is continuous. It keeps learning and adapting itself to improve itself based on data and the experiences it has had. So, one key characteristic of machine learning and AI now is ability to handle unstructured data. So, before we used to have Excel that powers structured data. So when you arrange your context, like you arrange the data, into rows, columns, and all of this structure, spreadsheets like Excel is able to interpret it correctly for you. You're able to understand patterns. You're able to spot patterns. You're able to draw graphs and everything, identify behaviors from just the structured data. So if machines are giving structured data, each machine excel at when you give logic, and if this happens, do this. If you give the structured information, it's able to excel very well. But when you now have unstructured information, like things like text, images, audios, videos, emails, that probably it has not been used to some of them before, how can you be able to make sense of it? That's when AI has improved in. So because when we have images, videos, emails, now the machine is able to see unstructured data. This is not structured, and is able to gather these things together and make sense of it. For example, if you put in your chatbot that I'm trying to see why this number is not correct, they upload the picture, so it's able to scan through the picture, examine what you're trying to say, and know this is the context of what you're talking from. Contextual understanding is where it's able to adapt to understand the nuances, context of information. So they process not just words, but sentiments, tone, and specific situation. We have interactive and stateful. This is where they may not get what you're saying. They now ask questions for you to clarify. And do you mean this? Are you trying to say this? So that they can give responses that are quite contextual and able to, at most, be able to solve the problem. Then we have adaptive learning, where it's constantly evolve, learn to become smarter, and then learn to become more accurate. So what we'll look at before we enter this class is cognitive computing versus the broader AI. So cognitive computing and AI, are a bit confusing, but cognitive computing is a type of AI in the first place. So AI is generally the umbrella or, every behavior that tries to simulate human intelligence. So from simple base rules to complex neural networks, everything is AI. So AI can focus on results without necessarily mimicking the process of human thought. But cognitive computing is more specific and more niche, in the sense that this is a subfield of AI that processes human or focus on human-like recognition or cognition and reasoning. And the goal is not just to solve a problem, it's looking at the way human will solve that problem, trying to mimic human reasoning and cognitive ability in solving very crucial problems. So let's look at an example. Look at it this way. Now, a calculator is very intelligent at maths, because it doesn't need to think to like a human, just an AI, which can just be able to, do calculation, functions, sorts, and do mathematical calculations very easily. So, but now we have an example of Watson by IBM Watson. Is having cognitive ability. So it can be able to understand natural language, judgment, give judgment, able to detect, this is used mostly in things like finance, detect fraud detection, analyze medical records for diagnosis, using customer service, use this for also cognitive input assistance. So where can it be applied? Cognitive computing, healthcare, like we said, it assists doctors a lot in diagnosing diseases, suggesting personalized treatments, and analyzing patient records. In finance, it can detect fraud patterns, risk assessment, even in cybersecurity is very important. Customer service, yes, it can be able to understand complex queries, go check the FAQ, reason human-like thought process. Legal research too is very helpful. It helps researchers to be able to look at immense volume of legal works, precedent, build cases, understanding nuances of language, legal language. Then for education, personalized learning platforms adapt to this because it gives student feedback and progress, and it's very, very helpful. So cognitive computing is very important because it helps to give this human-centric approach to AI, where AI doesn't just spit out information, but it's able to mimic human form of reasoning and judgment and sentiment in bringing out answers to questions. So I believe this has been able to help you to understand what cognitive computing is all about. Thank you for joining this class and join me in the next class.